Welcome everyone, this is video 3 in our factoring polynomials series. Today we're going to look at factoring trinomials of the form ax squared plus bx plus c where a equals 1. So let's talk about this part, this ax squared plus bx plus c. Well, the first thing to know is that the a, the b, and the c are numbers. Alright, so what can they look like? Well, things that we can factor would be something like x squared plus 5x plus 4. It has that pattern. We have something squared or quadratic, then something to the first power, and then really something that x could be to the 0 power, which means 1, which we don't write it. But we have that pattern where it goes from 2, 1, nothing. 2, 1, nothing. Again, another example. Y squared minus 6x plus 5. Now, whoops, I made a mistake. That should be a y as well. You need to make sure you have matching variables, but it doesn't need to be an x every time. And that's what I meant to show you, but then I had an x slip back into my mind. So we can't factor every trinomial. So these would be non-examples. These are things we will not be able to factor using this method. Just something random, 3a squared plus 4b squared minus 2. It breaks down because of this b squared. If it was an a, that would work, but it's not. Something like that, we'd try greatest common factor, and if it didn't work, we'd call it prime. Another example, just like 2x squared y to the 4th minus 5 x y to the 6th plus 7 x to the 4th, y to the 7th. Again, there are 3 terms, but it doesn't have the form where it's a variable squared, plus or minus just the same variable to the first power, plus or minus some number. So we are going to factor things that look like this and not this today. Here's our first example. Now, I'm going to show you 3 different ways to do it. One of the ways is my favorite, and for most of the video I'll use just the one way. But because I realize people learn different ways, I'm going to show you all 3 ways that I know, and you can pick your favorite. And if the method you like isn't the method that I use mostly, you can come find me or another teacher, and they can work on you with using that alternative method. Okay, so the first way, the first method I'm going to use, I'll use blue, is, well, it's called decomposition, but it's really grouping. It's just grouping with an additional step. So I'm going to show you the decomposition step, which is pretty easy, and then after that, it's grouping. So seeing you already know how to group, you might like this one. Okay, so the trick here is, like I said, we're really using grouping, but if you think back, grouping needs 4 terms, and this only has 3 terms. So the way we get around it in math is we rewrite the middle term as 2 terms. So it's going to mean 7x still, but it'll look differently. It'll give us 4 terms, then that'll allow us to use grouping. Now you can't just use any terms you want, so I can't just use 6x and 1x or 5x and 2x. They have to be a special set of numbers that add to 7. The way we figure that out is by doing the following calculation. It's not bad at all. You go, these 2 numbers have to be factors of the a value times the c value, and then these same 2 numbers have to also add to make the b value. So the a value is whatever's in front of your squared term. So there's nothing there right now. It's just a 1. So that's 1. Then the b value, it is the coefficient in front of the x to the first power. So that'll be 7. Oh, I'm sorry, that's the b value. So that would be 7 down here. The c value is the final term. So that would be 12. So I'm looking at 1 times 12, which equals 12. So factors of 12 that add to 7. Those numbers are the numbers I'm going to use to rewrite the 7x. So if you think of what numbers multiply to make 12 but also add to make 7, hopefully you think of 4 and 3. So I'm going to rewrite 7x as 4x and 3x. It'll still mean 7x, but it'll allow us to use grouping then. So I get x squared plus, now it doesn't matter what you write first. I'm going to say 4x, then I'll say 3x. If you went the other way, it would be fine. Now we have our 4 terms. Now we can use grouping. So again, here's my imaginary line. Pull out my GCF from the left side, x. I get x plus 4. Pull out the GCF from the right side. I see a positive 3. Then I get x plus 4 again. I got my matching binomials. I'm happy. So pull out my common binomial and write my leftovers down. There we go. That is one way to get this answer. The next way I'm going to show you is, it's called the box method. It's also called guess and check. People might like it, you might not. Both decomposition and this box method, they're going to work for all trinomials of this form, not just trinomials where a equals 1. All right, so you get more bang for your buck maybe with this. If you're not a math person and you kind of less is more to you, you might want to use the decomposition or box method, whichever one you like. The third method, which is a shortcut, a pattern, it's awesome, but it only works for a equals 1. So when a doesn't equal 1, you'll have to be using either decomposition or box. All right, so let's get back into it. The way box works is, I'm going to rewrite my polynomial. Again, it's really a guess and check method. You write a box, or that's the way I was showing it. And right here is where you put your first term, your ax squared term. So for this question, that would be just x squared. That's going to be this guy. In the second side, I guess I didn't draw this column here. There's two columns. In the second column, you put your c value. So that's going to be 12, this guy. Now, you have to think of factors of these things. So I'm looking for, in this column here, I'm looking for factors of x squared. Well, what two things equal x squared? Well, just x times x. And in the second column, now I'm looking for factors of 12. So what are some numbers that multiply make 12? Whatever you think about. We already know 4 and 3 are nice numbers for us, right? So I'm going to say 4 and 3. You could say 6 and 2. You could try 12 and 1, whatever set of factors. Now, with this box method, you then multiply on the diagonal. So that's going to give me x times 4 is 4x. X times 3 is 3x. These are my test numbers to see if I'm doing it right. What I then have to do is add these numbers up and see if they add up to my middle term, which in this one, the bx term, the linear term, is 7x. And again, that's the middle term, okay? And that's going here. And 3x and 4x do add up to 7x, which means these are my answers. My rows end up being my answers. So I was able to guess and check my way to the answer. So then I'd finalize it, equals x plus 4, x plus 3. I'll show you this one more time in the next example. All right, my third and my favorite, the way I really would like you guys to do it because it's the fastest, but I get it. If you're not a math person, you might not be able to use some of these patterns that require you to remember extra things. You might just want one thing that works a lot of times. I get it, and that's cool. Okay, so this pattern here. The pattern, it only works when a equals 1, okay? And the way the pattern works, it's kind of similar to decomposition. You're going to look for factors of c that add to b. So I didn't make a mistake. It's not a times c for this one. It's just c. So, and maybe I'll write this up here again, x squared plus 7x plus 12. So my c value is 12. My b value is 7. Factors of 12 that add to 7, 4 and 3. 4 and 3. My answer then is x plus 4, x plus 3. It's that quick. So this pattern is the way I hope you guys can, I hope you use this method because it's the quickest. It only works when a equals 1, but it's so quick and easy that students love using it. Okay, let's look at another example. Okay, we'll go back to decomposition. This is the last time I'll use all three methods. Moving on from here, I'm going to use just the pattern, and I'll speed the video up as well. So decomposition. Decomp. Okay, so I'm looking for factors of a times c that add to b. Okay, a ends up being a 1. C is a negative 15. So factors of negative 15. B is positive 2. So factors of negative 15 that add to positive 2, hopefully you can think of, that's 5 and negative 3. 5 times negative 3 equals negative 15. 5 plus a negative 3 equals 2. So then I rewrite my trinomial as a 4-term polynomial. So I'm going to write 5x minus 3x minus 15. Break it down the middle. Look for my GCF. It's x plus 5. Look over here. I see two negatives, so negative, and then negative 3. 3 is common, so then I would just get x plus 5. There's my matching binomials. Write those down, x plus 5, x minus 3. Now, I hope I'm not confusing you by showing you multiple methods. You only have to use one. You do not need to use all three. You pick what works for you, and we're going to move forward with that. Okay, the box. Okay, ax squared, that ends up being just x squared. The c value is negative 15, and then my magic numbers have to add up to just 2x. So with the box method, when a equals 1, the left side's a joke. It's always just x and x. Now, negative 15, you can play around with those numbers. 5 and 3 always pop up. Now, you can cross multiply without putting the signs in, and then work the signs after. Like, go, okay, so I'm going to add this up. That would add to 8. Well, what would I have to do to get it to be a 2? Well, it'd have to be a negative 3x, meaning this would have to be a negative 3. And that does add up, so meaning these would be my factors. X plus 5, x minus 3. Okay, and the third and the preferred method is this pattern. It's limited, but it's so quick. Limited in that it only works for when a equals 1, but that happens a lot too. So like you're going to have opportunity to use it. Factors of c, I know that's close to decomp, but it's not decomp, that add to b. C again is negative 15. B is 2. So we've already figured these numbers out, so it feels like we're kind of cheating here. And then I just go right to my answer. Now the way it would typically look, everybody, you'd have x squared plus 2x minus 15, and then right underneath that you'd put your answers. So x plus 5, x minus 3. All right, after this, we'll only use one method. All right, so let's move forward with the pattern. So we're going to have these binomials as answers. You put your answer right underneath your polynomial. So I'll do my little thinking work underneath. You don't have to use these blanks, but why not? It's pretty easy. So factors of c, this is c, so that's 6. That add to b, that's b, so that's 5. So factors of 6 that add to 5, thinking. Yes, 3 and 2, people. So then my answer is x plus 3, x plus 2. Or you could use decomp, or you could use the box. This is so quick. I suggest using this. Again, it only works when a is 1. So here, it's 1y squared. I can use the pattern. In c, it's 1x squared. I can use the pattern. Okay? If it was 2y squared, couldn't use the pattern anymore. So right away, I already know it's y and y. I can fill those in if I wish. Go to my little thinking portion. Factors of c that add to b. C is negative 8. B is 2. Let's think. Factors of negative 8 that add to positive 2. Thinking. Well, 4 and 2. Yeah. That makes sense, everybody. And then you got to make the sign work. So we're going to have a negative 2, because 4 plus a negative 2 would get you to positive 2. So it's going to be y plus 4 and y minus 2. So quick with this pattern. More. Again, notice that sometimes it's x, sometimes it's y, and this one it's t. The variable doesn't matter, just is it squared, and then is it to the first power. Okay, so factors of 6 that add to negative 5. We'll try this one maybe without showing our thinking. So positive 6 that add to negative 5. Well, hopefully you think of negative 3 and negative 2. Negative 3 times negative 2 is positive 6, and they add to negative 5. So you can do it without showing any work. And again, that's why people like this method so much, is it's so quick. This is x, this is x. I'll show my work, because if you can do it in your head, that's great. I don't have to show you anything. I don't have to teach you anything more. But it's the people who don't understand, I want to show you some more stuff. So I'm going to worry about you. C is negative 15. B is positive 2. So what multiplies to make negative 15? Adds to make 2. Think about it. Think about it. Yeah, 5 and 3. I like what you're thinking about. 5 and 3. And then again, 5 plus 3 is 8, but 5 minus 3 would get me to 2. So then they both have to be negatives. So x plus 5, x minus 3. So quick. Let's look at these examples. Example 2, they're a little bit different. Now we know a few methods, so we have to start getting a bit of a practice or pattern down. The first thing you should always try, always try, is always try to take out a greatest common factor. Not every polynomial has one, but when they do, it makes your future factoring so much simpler. So let's look at this one. If I look through it, I see that 2 is common to everything. So I'm going to pull out the 2, rewrite what I got. And then now what I do is I just factor the remaining polynomial. And I can see here that my a value is 1, so I can use my pattern. So what I factored out, the 2 in this case, it gets carried along. And then now I just go through my pattern. Factors of c, which ends up being negative 21, that add to b, and that ends up being 4. So 7 and 3, but it's negative 21, so one of them has to be negative. Negative 3 to get me down to 4 there. 7 plus a negative 3 gets me to 4. So x plus 7, x minus 3. B, again, look for a GCF first, and I can see one. Now, you always want the first term to be positive. In this ax squared plus bx plus c, a has to equal 1, a positive 1. So I'm going to pull out a negative, even though you can see here, this is negative, this is positive, this is negative. They're not all negative. Pull out the negative to set up your next factoring. So we always want to leave a positive first term when we can in our adjusted polynomial. So I'm going to pull out negative. And what's the number that's going to be common? 3. And then an x. So when I go through here, I do my division. I'm going to get x squared minus 6x plus 5. And now I factor this. And I'm going to use my pattern because the a value is 1. So negative 3x, what I already factored out, it gets carried along. And I'll just have 3 factors in my final answer. So factors of c, factors of 5, that add to b, which is negative 6. This was an easy hard one. Often people won't get it, and then they get the final answer like, oh gosh, why didn't I think of that? So we're going to go 5 times 1 is 5. 5 plus 1 is 6, but I want negatives. I want negative 6, so it must be negative 5 minus 1 is negative 6. And negative 5 times negative 1 definitely multiplies to make positive 5. And there we go. So again, look for a GCF first. Quick summary. There's a grouping method you could use. It's good, and we're going to use it in the future. We also call it the decomposition method. There's our pattern where a equals 1, and that's our thinking steps. And then there's our box method. Again, everything's great that I've listed here, but this is the one. If you can get it down, use that one. It's going to be quick, and quick is good in math. But you know what beats quick? Correctness. So whatever you're best at, whatever you feel most comfortable, use it. I'm suggesting pattern. I hope it helped. Have a great night, everybody.